All right, everybody, let's talk geometric series. Actually, let's talk geometric sequences. Ha! That's what I wanted to do. I was looking at my notes for series and I was getting excited. But we're going to talk geometric sequences first. It's going to be a list of terms just like our arithmetic sequences, but instead of adding a common difference, we're going to be multiplying by a common ratio. So, simple scenarios like the following: 4, 12, 36, 108, 324. Because I'm running out of mental math that I can do. So we look at something like this, and we can hopefully immediately notice each term is found by multiplying the preceding term by 3. Each term is found by multiplying the preceding term by 3. Now, this leads us right into a recursive formula. So, for example, in this one, we would have an plus 1 is just equal to 3 multiplied by an. So whatever your next term is, it's just 3 times the term you had before it. So this would be a recursive formula for this particular sequence. However, that's only going to be so helpful, and so what we're going to generally want is some sort of explicit formula. Okay, so if we're trying to figure out this explicit formula, it's actually kind of easier than the arithmetic ones. In fact, all we're going to do for this is just look at your first term. So your A1 term is equal to 4, and then whatever term we're going to, if we're trying to go to the second term, well, then we've multiplied by 3 a single time. So, A2, we can kind of think of this as 4 times 3. And then, of course, A3, well, is just going to be that term. So 4 times 3 times 3, which, all right, that's a tough way of writing that. We could write that as 4 times 3 squared. We can kind of keep going with this. So I realize, A4 is just going to be 4 times 3 squared times 3, because this is just, this A3 term, which is the same thing you have right there, but then, times 3. Okay, great. So that's just 4 times 3 to the third. And I just want us to make a very clear connection between the term that's happening here and the power that we're taking 3 to. So you have a 1 right there, and I suppose you could think of this as times 3 to the 0. You've got a 2 right there, and you could think of that as 3 to the 1. You've got a 3 right there, and it ends up being 4 times 3 squared. You've got a 4 right there, and it's 4 times 3 to the third. And so hopefully everyone, since it's a pre-calc class, everyone at this point looks at that and says, oh, okay, I kind of get the idea here. The explicit formula is probably an equals 4 multiplied by 3 to the n minus 1. Okay, so in general, what we're going to start recognizing is that our explicit formula for geometric sequences is going to be an is equal to a1 multiplied by r to the n minus 1, where, as usual, a1 is just the first term, r to the n minus 1, just r is the thing I'm interested in. Just r is what we're going to be calling our common ratio. In this example, it was 3, but common ratio, it's just the thing you're multiplying each term by to get to that next term. N minus 1 is it's just n minus 1. There's nothing to describe that, but n is really gonna, an is the term that we're on, and so this is just the way we say the nth term. Woo! Pause there. Got a little flustered. And so then n minus 1 is just, all right, whatever term we're on. If it's the 20th term, then we're just going to take this common ratio to the 19th power. If we're on the 57th term, we're going to take it to the 56th power, and so on. Just one degree less than whatever term we're on. So this is actually going to be really helpful when it comes to, sort of describing a different sequence that might be also geometric. So actually, let's keep it right there. Let's put our screen focus right there, and let's say we have this sequence. Oh, I don't know. Let's say we have 24, -12, 6, -3, 3 halves, ... So let's say we have this sequence over here, and we want to find the explicit formula for this geometric sequence. For this geometric sequence. Okay, so first things first, we do need to find this common ratio. We're trying to think, all right, what is that r? So we're multiplying 24 times something to get us to -12. So 24r equals -12. R equals -12 24ths, or -1/2. Very helpful. And we just kind of want to make sure that it seems like that's happening as we go. -12 times -1/2, yeah, that's 6. And 6 times -1/2, that's -3. So we're good. So it seems like that's working. -3 times -1/2 is 3 halves. Excellent. So r is equal to -1/2, and a1, well, it's just right in front of you. A1 is 24. And so if I would like to find the explicit formula here, it's actually not too bad. We're just going to say, great. An is just 24 multiplied by -1/2, and please, please, please do not forget to have parentheses. These parentheses are completely crucial. This is going to be something else if you don't have them in there, so always make sure you do that in parentheses. And it is to the power of n-1. Parentheses aren't completely necessary right there, but I kind of like putting them. I think it makes it a little neater. In fact, I'm going to fix it on the original formula too. So we can then, of course, use this to do all sorts of things. I could ask, what is the 10th term? So what is A10? A10 equals something. So that's just going to be 24. So A10 will be equal to 24 multiplied by -1/2 to the 10-1. So that does mean we're going to have to do, 24 times -1/2 to the 9th. But hopefully we all know our powers of 2 up to the 9th power? Maybe? I don't know. I'm counting on my fingers. I know you can't see me do it, but 2, 4, 8, 16, 32, 64, 128, 256, 512. So this is going to be -24 over 512. Because the negative is because we have a negative being taken to that 9th power, so that's going to be, and that's an odd power, and so it's going to be a negative value. And then we can simplify a little bit. I'll let you guys do this by hand, or heck, just use a calculator, but this would be 12 over 256, which would be 6 over, let's see, 256 divided by 2 is 128, and we can still go is 3 over 64, and we just barely fit it. Though, of course, I think from, your perspective, it might even make more sense to do it like this, and you might notice, oh, I lost all my negative signs, so these are all negative, so it's -3/64. There we go. Okay, so let's, in the next video, we'll do some, more challenging applications of this. But this is going to be the basic premise of the geometric sequences questions. Of course, we'll still get to series, which is when we're adding them all up, and that seems like it'll probably be a lot harder than arithmetic series, but that's okay. Okay, next video.